just take a screenshot. All right. Yep, I got it.
Thanks. Can't get my screen back.
Yep, yeah, I got it.
There we go.
All right. Yeah. So for this problem, they're giving you a lot of words and everything. But I mean, none of that's really important. The only important parts of this is like that last part where it tells you to find the instantaneous rate of change. So when you're finding an instantaneous rate of change, you're just taking the derivative. So if we take the derivative here, p prime of t, since we're multiplying this entire thing by a constant times any derivative is just going to be a constant. So we're going to leave that 1/3 out front. And then the derivative of the inside is 2t plus 1. All right. And then David, I'm not sure what homework.
This was David. This wasn't homework.
Really
this is one of the I think it was like one of the quiz questions or something. I just had a little trouble on.
Okay. And then it's asking you to find that instantaneous rate of change at t equals 4. So we're plugging in 4 for this function.
Oh, yeah.
So when we do that, we get 1/3, and then 2 times 4 is 8, plus 1 gives us 9, which gives us
3% per day.
Mm-hmm.
Gotcha. Yeah, I just you know, when you look at it like that, it's a lot simpler than. There's definitely a little shock value when you first see the question.
Yeah. Yeah, that's the thing. Like when I try to tell people, if they ever. All right, guys. Sorry, I was just talking to the other class for a little bit, but yeah, we can do this problem really quick, and then I'll probably have to switch back. So for this problem, to differentiate this, our -4 right here, that's just a constant, so that can just stay where it is right now. And then the derivative of e to anything is just going to be itself. So we have e to the 3x. But then we have to apply the chain rule, and we have to take the derivative of this 3x. So we have to, and then that's going to be 3. So we multiply that by 3. And then when we simplify this down, it becomes -12 e to the 3x. Does that make sense? All right. Let me just check on the other person really quick. I mean, you two can talk amongst yourselves if you want to help each other with like. I'm sorry, what was that?
I can't hear Ryan unless he can hear me.
I don't know if his microphone is working, or I don't know if he's talking right now. I think he can hear us, but I don't know if...
I guess I can talk to him. You can hear me. Yeah, and this one, actually, this one I had a question about after I looked at it. What he did was he put parentheses around the 5x2, and times parentheses e3x, and then he brought that down, and that was the 5x down, and it was 10x times e3x plus 5x2 times e3x times 3. So you're basically doing the product rule.
All right, hey guys, sorry about that.
I was telling Ryan we did this one last night, and I told him what we copied down there. or what we did. And then as I look back at it tonight, the answer to it was like 5x 3e e3x parentheses 3x plus 2. And but I copied down 10x, so I don't know if I did something wrong, or I think it's because we factored out at the very end and I didn't copy that last step down correctly.
Okay. All right. So since we did this yesterday, what's the first step we should do?
I liked your idea of putting those parentheses around that 5x2 and the and the e3x made a lot of sense to me.
So yeah, putting the parentheses definitely helps at first if you're not comfortable with like seeing these problems, or you can just kind of recognize that they're separate terms, both with like an x variable. So you would just treat it as like a product of two terms.
Recording stopped.
All right. So what's our first step?
Going to put the 10x times the e3x. So we're basically taking the first time times the or the derivative of the first term times the second term, and then the first term times the derivative of the second term.
And our derivative of the second term
is going to be e3x times 3.
Yep. So after we do,
now where?
I'm sorry. Yeah, what was that?
Is that 3 went down in front of the e, basically, right? I mean, if you were like doing it.
Yeah. So I mean, this 3 is just another thing multiplied by it. So you can just multiply it by the 5, and you can put it in front of. I mean, you can put it in front of the e. You can put it in front of the. I just put it with the 5 since it's just a constant, and you can multiply it through.
Okay.
For this part, all you're doing is taking out a 5 because it's in every single term, and you're taking out an x and an e to the 3x.
That's what I didn't do last night.
So then your first term is 2 plus 3x.
Okay, yeah, that makes it right. I just didn't copy it down right.
All right, does that make sense to you as well, Ryan? All right. Yeah, I'm glad you found out about this because I was going to tell you on Tuesday that we were offering it on Thursday as well now. So just wanted to. I'm glad you found out.
Yeah, I think they said it. I think the guy who works with Larry? I think Larry sent out an email.
Okay.
So.
Hey, Jake, and it says that these sessions are recorded. Is there somewhere where we could go back if we wanted to watch a session?
Yes, exactly. I was talking to David about that. You should be able to find the recordings if you go on Blackboard and you go to the same area with the Math 121 Collaborate classroom.
Yeah.
I think that's where you went. And there should be a place that says scheduled sessions, and then right next to that it should say recordings. And you should be able to find all the recordings from, I've been recording pretty much every single session except like the very first couple. But you can just change the date and you can always find these recordings. And it's just going to be, these recordings are just like basically what I'm doing here. So if you ever miss a session, you know, they're not like, they don't go over everything, but they just go over probably specific homework problems that you might have similar issues with.
Right, exactly.
I hope I didn't say anything stupid.
Everybody says something stupid except for Jason.
I know.
I know.
He's going to be a doctor, though. We're just a bunch of dummies.
I wouldn't say that, but
I can tell you how to work on airplanes now. That'll be about the end of it.